These are the system interview questions related to certificate authority. It is the last chain to make your connection secure. So before going to anything, just I want you to pause this screen and read all these questions. If you know the answers, then this lecture is not required for you. But if you are hesitating at any answer, then I will recommend you to definitely watch it. So first, stop this screen and try to answer these questions first. Okay, so I guess you have already summarized the things, even it is required, or it might be possible that it is not required for you. So if it is required, then stay with me because we are going to understand what is this cornerstone, this certificate authority, how it is creating a trust for us, how this creating an additional layer in the secure connection over the TLS. So this is the part in which you are going to understand all these things. So let's start with the visual representation so that we can relate it a bit more. Okay, so here is the certificate authority and it is called as the chain of trust. So to understand this, how this certificate authority work, first we need to understand the problem statement, that what is the problem and why these CA certificates are required. These SSL certificates are required. These CA certificates are nothing but the SSL certificates. So here, what I will say, I have this user is using some application and that particular application is hosted over this web server. Okay, so let's say user is going to use the bank.com and this bank.com is hosted at this web server. Okay, so here is the bank.com, and till now we know that these two will create some pipeline between them, which will be over the TCP or QUIC, and they will do the TLS handshake. After doing the TLS handshake, they will make sure that okay, all the encryption keys are transferred to each other. They know that what kind of encryption they are doing so that they can decrypt it and they can use it for their purpose. But let's say there is this hacker. Okay, it is the hacker. And what hacker did, this hacker created the bank.com. It is very similar application this hacker created. It have the similar visual representation. It have these similar features, which is showing as a button or some input fields. And somehow this hacker is able to give this URL to the user. So in place of the valid URL, this hacker created this bank.co. It might be possible that the user have created this bank.co, or it might be possible that user have the same domain, this bank.com, and somehow this hacker is able to provide this particular URL to the user, and now user is going to use this bank.com to create the TCP QUIC connection over the TLS with the hacker. So right now, this hacker, what it will do when user is going to send its username and password or the OTP, these details will go directly to the hacker, and this hacker will use this information to do the bad stuff, to do the bad stuff. Okay. So how, like, we have followed all the things for the TCP, for the QUIC. We also did the TLS handshake, but still our data is not secure. So to make it secure, what this internet did, this internet introduced the SSL certificate, SSL certificates. What these SSL certificates will do, these SSL certificates will be available to your web server. And when these web server, when you try to reach this web server at the browser, you are going to use some browser or application to reach to this particular bank.com. What it will do, every time this web application will send these SSL certificates to your browser, and because of these SSL certificate, your HTTP become HTTPS. This particular S is provided by the SSL certificates. And also, In Chrome, you must have seen that sometimes when you try to open a website, it shows not secure, or it shows like this HTTPS is not supported. And also sometimes when you are not seeing any kind of error, then definitely you will find one lock sign at the URL part where you will identify that, okay, this particular URL is secure to use. So these all things are provided by the SSL certificates. But how these SSL certificates do all these things? That thing we are going to understand in this particular part. What kind of security layer it will provide and how this hacker is not able to replicate this SSL certificate. Okay, so for that, what I will do, I will just drag it up, and we will create a fresh canvas. Okay, so here, what it will do. Okay, so here, let's. Okay, so here is the user. Here is your web application, and now we will use the term certificate authority. This CA is certificate authority. Okay, so this certificate authority, when you are going to use your mobile or your PC, it might be your desktop or laptop, anything. So when you use these mobile and PC, you will these all hardware comes with the loaded TA public PUB public key. What is the CA public key? This certificate authority is an organization, and this particular organization is the one which is responsible to validate all the URLs available over the market. And this is the one organization which issue the SSL certificate to all the web application. So what this CA certificate do, when you purchase your mobile phone or your desktop or your PC or your system, you there is one directory where you have this CA public key already loaded. It is provided by the Microsoft, it is provided by the Apple, or whatever the hardware or whatever the company you are using. Now comes to the part of web application. So when you create a web application, to make it secure, to make it HTTPS, you request some certificates from the certificate authority. And what these certificate authority will provide you, it will provide you uh, what it will provide you. It will provide you leaf certificate, and intermediate intermediate certificate authority certs. So these two certs are provided by the main CA to this particular web application, and this user's hardware also got some loaded CA public key into their system. But how these all things work together with each other? So now let's understand the flow with the browser. Okay. So, okay, I will drag it up. So we can go to the browser and then we can understand how these keys are work together. Okay, so for that, what I will do, okay, I will use the white. So here is the user. User is going to use the browser to access this bank.com. And this user is using some system. I will call it a system. It can be your PC or phone. It can be anything. So it have this already loaded public CA cert or key. Uh, CA authority key. Okay, so it have already inbuilt. When you purchased it, then you got it. Okay, so here is the web application. So when this web application send when this web application is connected with your browser, let's say you have typed this www.bank.com, then you see this particular page opened at your browser. So at that time, what this web application did, this web application sent its HTML or sent its JSON to your browser, and that browser rendered that particular data and showed you whatever this particular web application is providing. That particular domain which you have typed on your browser is providing. So when this web application comes to your browser, before loading, what it will do? It will, as I told you, like this CA will provide the leaf and the intermediate. These are the two certificates which are provided to intermediate certs. These two certificates are provided to web application. So web application will send its leaf cert and this intermediate cert to your browser, to your system from where you are trying to open it. So now when browser got these two things, leaf cert and intermediate cert, what it will do? It will these certificates contain some data, and that particular data is validated by this public CA cert which is available at your browser, at your system. The browser will go to your system, and this browser will ask for the system to validate these all things, and then only it will allow that particular URL to be connected in the HTTPS. But how this leaf cert and intermediate certs are validated with the public CA cert available at your system? Okay, so for that, what we will do, we will understand again in a fresh flow. Okay, okay, fine. So here, currently it is our browser, and browser have the access to public CA cert. Okay, and right now from this web application, it got the leaf and intermediate. These are the two different certificate. Let's talk about the data which is present inside the leaf and intermediate. Then we will comes for the validation. So inside the leaf, you will get the domain name. You will get the public key. I will tell you why this public key is present here, and issuer name, which organization issued it, issuer name, and also the digital signature. What comes inside the intermediate? Inside the intermediates, we have again the public key, we have the digital signature, and also we have the subject. The subject contain like uh, the company name which issued this particular intermediate public key also. Sorry, this intermediate certs also. So these two certificate contains these type of details like these three and these four. So currently we have this leaf certificate and this intermediate certificate at our browser, which is provided by the web application. Now let's come to the part of validation. Okay, so what I will do, I will just drag it a bit till the leaf and intermediate, and now, okay. So what this intermediate will do, so this, okay, so for the leaf, we have the public key, okay, and we have the digital signature. So what it will do, public key of the intermediate certificate, public key of intermediate certificate, and it will use the digital signature of the digital signature of the leaf certificate. This leaf certificate is also called as website certificate. So what this particular do, these two will calculate a hash. These two will be used to calculate a hash. And after calculating the hash, it will provide the data of domain name. So who will do the calculation? Browser. So here is the browser. browser will collect the public key from the leaf and the public key from the intermediate certificate and the digital signature from the leaf certificate. After collecting this public key and digital signature, what this browser will do, browser will create a hash, and this hash will provide the data of domain name, public key, and issuer name. So after getting these all details, it will try to match these details with these details which are present here on the leaf. So from here, it verified that yes, okay, this particular leaf certificate is correct. It is correct because after calculating the hash, I got the same details which are available over the leaf. Now comes the part of second validation. Now we are going to validate the intermediate certificate because this intermediate certificate is used to validate the leaf certificate, the website certificate, and after verifying the leaf certificate, it is the duty of the browser to validate the intermediate certificate as well. Okay, so how we are going to validate the intermediate certificate? Okay, so for that, coming back to the intermediate cert, again, we got the public key, we got the digital signature, and also we got the subject. And inside my browser, there was the public key of CA, public key of CA. It was already available at my browser. So we will use the same mechanism which we did for the leaf certificate. So what browser will do? Browser will take the public key of the browser and it will use it with the digital signature. We don't need to understand what math it is using to combine it and extract it. All we need to do is to understand it, like what part is matching with which part. Okay, so the browser which we have in our system and also the browser which have the access to the public key of CA which is available in my system, what it will do, it will use the public key to match with the digital signature and it will provide the output of public key and the subject. Again, this data will be compared with the data which is available inside the intermediate certificate. And once it is verified, then the browser will say that, okay, all the data which I got from all the certificates which I got from this particular web application, those all are valid. And now this application can be used as HTTPS. If anything, if any minor details also got failed in the validation, then it will not allow this application or this URL to be open from the HTTPS. It will be just HTTP, not HTTPS, and you will find this not secure syntax at your web URL section. So in this way, these all things are validated. But how this particular thing prevent us to be attacked from the hacker? Okay, so again, now we understood the process, like what validation it did. Now it's come the part like how it is preventing the hacker to do the same. Okay, so for that what is the mechanism? Okay, again, we need the browser have this public CA cert, and this CA, this certificate authority organization, it's a very big boss organization, and it is the one which provided its public certificate to this system in which you opened the browser. So let's say here is the hacker, and this hacker is trying to do the same mechanism which we understood till now. So what this hacker will do, this hacker will also create the leaf certificate and the intermediate certificate. It might be possible that this leaf certificate is correct. it is identical to the certificate which is provided by the CA organization. But when it comes to the intermediate certificate, this intermediate certificate is the one which contains the detail about the organization, which is this organization which issued this intermediate certificate. So when the public key present inside this browser is matched with the intermediate certs digital signature, it provides the detail and that detail will not match. So here, when these details will not match, it will not allow the HTTPS, it will allow only the HTTP. And when it will allow only the HTTP, you will see that not secure tag at your URL, and you can understand that, okay, it is possible that this particular website is not correct. This particular URL is not secure. I should not enter any detail in this URL. There is also a second case. It also might be possible that the certificate which was issued to a particular URL, those certificates got expired and that particular application didn't renew it. So that is why you also can see the HTTP in place of HTTPS. But still, if you are seeing this HTTP in place of HTTPS, you should never enter any details in that kind of URL. Even you should not open it. So it is the complete mechanism, what happened behind the scene, why these SSL certificates are required, why this CA is so much needed when it comes to secure your application. So now coming to the part, we need the TCP or QUIC, then we need the TLS, then we need the SSL certificate. So these are the things which are making your application very secure to access, and you need to understand that where to integrate it, where to create a pipeline, how to code this TCP QUIC, how to use the TLS latest version, how to configure your SSL certificate so that it will not create any burden to anyone. When I'm saying like creating any burden to anyone, so let's assume you are using you have created an application, and that application have around 10,000 of server, because your application is so large, billions of people are using your application, and you have 10,000 servers available over the internet, which are serving to these billion customers. So are you going to install these SSL certificate to all those nodes or all those servers where your web application is running? The answer is wrong. It is not the correct way. You need to install that SSL certificate on the ingress controller, which is Nginx. This Nginx is the one which stand in front of your web servers and also in between the customer and the web application. This Nginx stand in between, and this particular certificate should be installed at the provided at the Nginx or at the ingress controller, and that Nginx will handle all the SSL related activity. Okay, so these are the very simple insight. But first, we need to see the questions, and then we will try to answer them. What they are asking us. So you mentioned that a hacker could intercept a request, send their own public key. If a hacker intercept the connection and send a fake leave certificate with their own public key, how exactly does the browser know it's fake? So as I told you, it's just not about the leave certificate. It's also about the intermediate certificate as well. So inside the intermediate certificate, it not might, it will definitely, because these certificates contains the data about the certificate authority organization, like who issued it, when it got issued, and what's the serial number. These all details are there, and when these details will not match by the browser, because the CA public key is present at the browser, and that particular key will go and try to uh, create the hash out of that digital signature, which is available over the leaf certificate and intermediate certificate, and it will find that data is not matching. So that is why this hacker will not be able to intercept the connection by using the fake leaf certificate. In your explanation, there are three certificate: root, intermediate, and leaf. Why do we need the intermediate CA? Why does the root CA just sign the leaf certificate directly to save time? So just assume that you are directly using the root certificate in place of intermediate certificate. This root certificate is the one, this root certificate public key is the one which is used to validate lakhs of millions of URLs available over the world, available over the world. And somehow, if you are going to use the real root certificate in place of intermediate certificate, it might be possible that at some point you are going to expose the private key for the root user, for the root certificate. And if anyhow you compromise that private key of root certificate, then it will create danger to all the URLs available over the internet. And we do not need that. So for that only we create the intermediate certificate. These intermediate certificate comes from the root certificate, and it can be created multiple times. Let's say if any intermediate certificate got breached or got corrupted, then particular intermediate certificate will be cancelled and new intermediate certificate will be created. And also these intermediate certificates are not single, like they create multiple intermediate certificate as a region wise, as a country wise. So if let's say if any one intermediate certificate is got corrupted, then they will remove that and some only few people will get affected in place of affecting the complete world. Okay, so I guess I have gave you some answer, but still I want you to go to the description and read the complete full answer of it. Let's apply this to a large scale system. If we design a system for google.com with 10,000 backend application server, do we need to install the leaf certificate and private key on all 10,000 servers so that they can do this handshake with the user? As I told you, we are not going to install these things into the servers because it might be possible that first of all, it will create the overhead, it will take the space, it will create the overhead, and it is not secure to install these keys on all the servers because any server can be hacked. So what we will do, we will use these certificates on the ingress controller like Nginx, and from there we handle these all the traffic. Okay, so you correctly noted that root CA sits inside the user's computer provided by the Microsoft Apple. What happens if a user is using a very old computer that hasn't been updated in 15 years and try to visit our newly secured website? So in that case, what will happen? It will show non-secure to all the website because it might be possible that your system contains some roots CA certificate which is totally expired and it need to be renewed, and because there was no any update by the system or by the OS at your system, then it might fail all the validation which is going to happen even on a valid sites as well. So these are the answers to the questions, and I hope that I was able to explain you a thing. In the next part, we are going to understand just very as small and basic the difference between the HTTP1, HTTP2, HTTP3. We already know we have understood it till now, but still these are the terms which interviewer can ask you to make you confused between the concepts. So that's why we are going to cover this HTTP 1, 2, and 3 in the next part. So stay tuned. And if you like it, then please subscribe it, like it, and comment it. Thank you.